All right, in section 4.3, number 35 through 40, we're asked to find the equation given these graphs. Basically, we need to find A, B, C, and D and stick it into that standard equation. So the first step is to find A. So A, or the absolute value of A, is going to be the distance between that center line and the peaks. So that distance or this distance, and they'll be equal. And that distance, it's going from, let's see, 11 to 7. So that is 4. And I can kind of decide if it's going to be a positive or negative A and decide where that starting point is. So I'm going to go with a positive A so that my starting point is right here. So I'm going to go back a little bit on that grid. So if my sign starts here, then it goes that way, then A is a positive 4. And that means that my graph has been shifted left a little bit. So that's going to affect my horizontal shift. So I'm going to do that in a different color. My horizontal shift is going to be left. I'm not sure how much yet. Let's see. Let's find the period first. Okay, so let's find B. So to find B, I need to find period, because B is equal to the period of the parent function, which is 2 pi, over the period of this function. And I can find P in the graph, so one full cycle. I might not have the cycle that starts at 0 in this graph, but I do have a cycle that starts right here and ends here. It will start repeating after that spot. So that distance is 45 to, each one of these tick marks is 45. So this tick mark would be, I know that because I'm split the 90 in half to get that first one. So this tick mark would be 405. So 405 minus 45 tells me that the width of this whole cycle is 360. So if P equals 360, then B equals pi over 180. Oops. So B equals pi over 180. So I have A and I have B. I need to find a C. In order to find C, I have to look at the horizontal shift. So I decided that we're going to shift left. There's two ways you could shift. You could shift left and land right here as your starting position, or you could shift right and land right here. And it's going to be, it's secular, it's period, so it's going to look identical to shift left or shift right. I'm going to shift left because that's our primary cycle. It includes that y-axis. So that's our primary cycle. So we'll shift left, and we just got to figure out how much did it shift. Well, I remember my rule of force, and my rule of force has that primary rectangle going back. It's split into 4 pieces. The first piece ends on that point, the second piece, the third piece, and the fourth piece. Each one of these little pieces is 90 degrees, or 2 tick marks. Oh, I'm sorry, not degrees. Sorry, it doesn't say degrees anywhere. I messed up. Just 90. It doesn't have any units. So if that's, each one of those widths is 90, this one's 92. 45 is right here. That means it must be going back 45. So it has a horizontal shift left by 45 units, whatever the units are. Okay, and then and horizontal shift equals C over B. So if C over B equals 45, then that tells me C equals 45 times B. And B I decided is pi over 180. So C equals 45 times pi over 180. So that reduces to pi over 4. There's 4 45s in 180. So that gives me that C equals pi over 4. And our D, whoops, I need a new color. Let's go with orange. Our D is the vertical shift. So in other words, this is our center line right here. It starts, the parent function has that center line on the x or the t-axis. It's been shifted up by 7 units because it's now at 7 between the 6 and the 8. So that means D equals 7. Now that I have all 4 of these parts, I can plug that into this function or this formula. I get y equals A is 4 sine of B, which is pi over 180 degrees. Oh, sorry, not degrees, sorry, just 180. T plus C, which was pi over 4, plus D. Oh dear. Yes, that's right. Yeah, C is positive because the shift left. Yes, that looks good. Okay. So that is my final answer.